For a long time, the moon was quiet. After Apollo and the Soviet landers, most of the world believed the moon was finished, explored, and understood. But that assumption turned out to be wrong, because while attention shifted to Mars and beyond, China went back to the moon and found things no one expected. Not just new images, not just new rocks, but discoveries that are forcing scientists to rethink what the moon really is, and what humans might actually do there next. In the 2000s, a new race slowly restarted. Not a loud flag-waving race, but a careful one. China built a plan with patience, step by step, mission by mission. They named it the Chang'e program, after the moon goddess from Chinese legend. And over time, that plan led to 3 huge moments: exploring the far side, bringing moon rocks back, and uncovering clues that could shape future energy and space bases. China's space agency, CNSA, was building a ladder. First came orbiters, then landers, then rovers, then sample return. Each mission was considered practice for the next one. In 2007, Chang'e 1 became China's first lunar orbiter. It mapped the moon in 3D, scanning hills, craters, and wide flat plains. Soon after, scientists noticed something in the data that got people excited: helium-3. It is a rare type of helium on Earth, but the moon may have more of it trapped in its dusty soil. Some researchers believe that helium-3 could be useful for fusion power one day. Fusion is the dream energy source, powerful and with far less waste than old nuclear fuels. Helium-3 isn't a magic battery that you can plug in tomorrow, but the idea changed how people looked at the moon. Suddenly, the moon was not only science, it became a target for industry and national pride too.
In the years that followed, scientists carefully analyzed the lunar samples, including those Schmidt had collected. They discovered that the moon's soil contains a surprisingly high amount of a remarkable form of helium, known as helium-3.
In 2010, Chang'e 2 flew even closer to the surface. Its job was to take sharper images and help choose safe landing spots. This was China setting up for the next big leap, a soft landing. That leap arrived in December 2013. Chang'e 3 touched down in Mare Imbrium. It was the first soft landing on the moon in decades, and it made China the 3rd country to do it successfully. Then the rover rolled out, U2, the Jade Rabbit. U2 wasn't just a cute name, it carried serious tools. It explored the surface and helped test how machines survive the brutal moon environment, like the radiation and huge temperature swings. Chang'e 3 also placed an ultraviolet telescope on the moon, turning the surface into a quiet platform for space observation.
In that, they need to control a robotic arm 380,000 kilometers away, and this requires millimeter-level precision. The lunar rover called U2 found there are 11 chemical elements.
But the biggest surprise was still ahead. In 2019, China targeted the far side of the moon. This is the half that always faces away from Earth. You cannot talk directly to a lander there because the moon blocks radio signals. To solve that, China launched a relay satellite called Quikao, often described as a magpie bridge. It sat in a special position in space where it could connect both Earth and the far side, passing signals back and forth. The Chang'e 4 descended into Von Karman crater inside the South Pole Aitken Basin. The basin is enormous and ancient, like a giant scar from a deep impact long ago. It may expose material from deep inside the moon. The rover U-22 started sending messages back. Scientists were stunned. The far side looked rougher, more craters, fewer smooth lava plains. It felt older, including signs of deeper material. Even when politics kept NASA and China apart, the achievement was hard to ignore. Humans had finally explored the moon's hidden face.
But now the Chinese have used a satellite much farther out in space to direct their probe, and scientists around the world are excited about what it might find.
Then came another historic move, bringing samples home. In December 2020, Chang'e 5 returned to Earth carrying about 1.7 kilograms of lunar soil and rock. It was the first lunar sample return in over 40 years, and fresh samples are a big deal. They let scientists test new ideas with modern tools. One big result was about the moon's timeline. The samples hinted that parts of the moon stayed active more recently than many people thought. In simple terms, the moon's story did not end as early as some textbooks suggested. Another claim that grabbed the headlines was a newly identified mineral in the samples called Chang'e. Reports linked it to helium-3 traces inside lunar material. Whether helium-3 becomes a real energy fuel depends on future technology, but the excitement showed that something is important. The moon is not just dust, it is chemistry, history, and resources.
The Chang'e spacecraft launched itself skyward in a high-stakes emergency escape drill, proving it's ready to carry takenauts to the moon. This wasn't just a test.
China's missions also created moments of mystery that went viral. In 2019, U-22 spotted something shiny in a small crater. People online guessed some wild things. Liquid water, alien debris. Later, it was explained as impact melt, rock turned into glass by a meteor strike. Still, that glass matters because it records violent events in deep materials. In 2021, another viral moment happened, a cube-like shape on the horizon. Social media called it a mystery hut. The rover drove closer over time and the shape became a more normal-looking rock from a new angle. It even resembled a crouching rabbit, an accidental joke from the Jade Rabbit rover itself. These moments show why space exploration hooks us. First wonder, then the real answer. China also tried something tiny but powerful: growing life. Chang'e 4 started a small sealed biosphere with seeds and organisms. For a short time, a cotton seed sprouted. It did not survive the freezing lunar night, but it did prove a key point. Biology can start in lunar gravity, even if survival needs better heat and power. A small green sprout on the moon might sound like a footnote, but it is a preview of future bases.
On January 2nd, China's lunar lander Chang'e 4 has successfully reached the far side of the moon, becoming the first probe to ever land on that side.
And the story kept moving. In 2024, Chang'e 6 reportedly brought back nearly 2 kilograms of samples from the far side, something no mission had done before. If confirmed and studied, far side samples could help answer big questions. Why are the near side and far side so different? What is hidden in the oldest basins? Next missions, Chang'e 7 and Chang'e 8, aim toward the lunar South Pole. That region matters because some craters never see sunlight. Their floors stay colder than minus 200 degrees Celsius, which may preserve water ice for billions of years. Water is everything in space. You can drink it, split it into oxygen to breathe, split it into hydrogen for fuel. If you can live off the land, missions get cheaper and longer. Chang'e 8 is expected to test building methods too, including 3D printing with lunar soil. The goal is not just visiting, it is staying.
It would look very similar to the close-up of a bird's bone. Like a bone, it is light and incredibly strong at the same time.
China and Russia have also talked about a long-term lunar-based concept, often described as the International Lunar Research Station, planned for the 2030s. At the same time, the US and partners push Artemis and related agreements. That raises a tough question. Who owns the moon? The Outer Space Treaty says no country can claim it like land, but it did not fully predict resource zones or private companies extracting materials. Now countries are testing the gray areas, not with armies, but with rockets and rules. In the past, the space race was measured in flags and first steps. Today, it is measured in supply chains, landing sites, water ice, and who can build a lasting presence. China's moon missions show one clear thing: the moon is back, not as an old trophy, but as a future toolbox. And the biggest question is no longer can we return, it is who will stay and what will they build.